We're going to take a look at this first example. I need to solve for the missing side length of this right triangle. I notice that the missing side length here is the hypotenuse. So in our formula of a squared plus b squared equals c squared, I know that our x value, since it's the hypotenuse, is our c value. The other two legs, the lengths of 2 and 6, you can let be either a or b. That part does not matter. So from here, I'm going to substitute the values in. So my a value, again, is one of my legs. I'm going to let that one be 2. So 2 squared plus my other leg over here is 6 plus 6 squared equals my c value, which is the hypotenuse, is our unknown, so that is our x squared. From here, you need to evaluate these squares. So 2 squared means 2 times 2, and I'm going to get 4. 6 squared is 6 times 6, which is 36. And again, those are going to equal x squared. From here, we need to clean up the left-hand side. 4 plus 36 is 40. And from here, we have one more step. All right, we are not done because I don't want to solve for x squared. I just want x. So in order to undo this exponent, we need to take the square root of both sides. By doing that, I'm just left with x. Now, square root of 40 can be simplified. So when you look for the largest perfect square that goes into 40, and I know that that is 4, so I can rewrite this as root 4 times root 10. Square root of 4 is our perfect square. That simplifies down to 2. Square root of 10, I do not know what that value is, and that is equal to x. So the hypotenuse of this right triangle using Pythagorean theorem is going to come out to be 2 radical 10. So that is one setup you're going to see. The second setup here is where we are solving for the missing side length, but in this case, it's a leg. Again, my hypotenuse, I think it's best to identify that first. That's always going to be your c value. And your other two legs, does not matter what you name them, are going to be a and b. So this time our setup is going to look a little different. A squared plus b squared equals c squared. This time I have my a squared, one of my legs, is the unknown. My other leg, the b squared, is my 11 squared. And I do know my hypotenuse here, so that is equal to 13 squared. All right, from here I need to evaluate my squares again. X squared plus 11 squared is 121, and 13 squared is 169. From here, I need to bring the 121 over to the other side by undoing this addition. The inverse of addition is subtraction, so I'm going to subtract 121 to both sides. This will cancel and become 0, and I'm left with x squared equals 48. Again, in order to undo this square, I need to take the square root of both sides. That will cancel out that exponent of 2. And I'm left with x equals, now the square root of 48 can once again be simplified. The largest perfect square that goes into 48 is 16. 16 times 3, so I can divide or set those both up as radicals. Evaluate our perfect square. The square root of 16 is 4. X equals 4 radical 3. And in this case, this is the length of the missing leg of this right triangle.